I'm Anusha Gillespie, and I share stories with meaning because we work hard all day and deserve a bit more fun while we learn. Today's story comes from Greg Lambert, Chief Innovation Officer at Jackson Walker, blogger at 3 Geeks and a Law Blog, and co-host of The Geek in Review. This story is all about legal AI. Beyond the Model, How Legal AI Really Got Smart by Greg Lambert. Introduction. For the past couple of years, lawyers and technologists have marveled at how AI-powered legal research tools seem to be getting smarter every month. Tools like Lexis Protégé, Westlaw CoCounsel, and vLex Vincent deliver answers that feel almost prescient. The assumption was simple: better models equals better answers. But as Jesse, a data scientist at a leading legal information company, explains to Cooper, a law firm innovator and librarian, the truth lies deeper in the stack. The real breakthrough isn't in how AI thinks. It's in how AI reads. This story follows their journey from a chance conference conversation to late-night video calls, a visit to Jesse's lab, and a final flight home as they uncover how advancements in vector databases and retrieval-augmented generation are quietly transforming legal AI. Part 1. The Spark at the Conference. The hotel lobby buzzed with the background noise unique to legal tech conferences. Half caffeine, half optimism, entirely too much jargon. Cooper balanced a paper cup of burnt coffee in one hand and an overstuffed swag bag in the other, weaving between clusters of attendees debating AI's future like prophets at an ancient symposium. "Cooper, you made it," called Jesse, waving from a corner table near the windows. He was a few years younger, wearing sneakers that didn't belong in a room full of Navy suits. His conference badge read, Jesse Tanaka, Lead Data Scientist, Legal AI Systems. "Jesse," Cooper grinned. "Good to see you again. I was just thinking about our last conversation, when I said the AI research tools seem to have leveled up lately." "Yeah," Jesse stood to shake his hand. "You mean how they've started giving answers that don't make you want to throw your laptop across the room?" "Exactly," Cooper laughed. "I figured it was all thanks to better models. GPT-5, Gemini, whatever version of Claude we're on now." Jesse smirked. "That's part of it, but it's not the full story." He reached for a napkin and clicked a pen from his lanyard, flattening the paper against the table. Everyone assumes smarter LLMs are the reason AI feels smarter. But the real leap isn't in the thinking part. We didn't make AI smarter. We taught it how to read. Cooper leaned in as Jesse drew a box labeled LLM and another box beside it labeled knowledge base. Between them, he had added an arrow that said retrieval. "Here's how this works," Jesse said. Old school language models were like law students taking a closed book exam. They memorized what they could, and that was it. The moment you asked about a new case or a niche rule, they hallucinated, made stuff up. Their training data was frozen in time. He shaded in the second box. RAG, or retrieval-augmented generation, changed that. It turned the test into an open book exam. Instead of guessing from memory, the model looks up relevant material in real time before answering, like giving the AI access to the entire law library seconds before you ask a question. "So RAG is the research assistant," Cooper said, nodding slowly, "and the LLM is the one doing the writing." "Exactly. The model doesn't have to know everything. It just has to know how to find everything." Jesse began drawing a chain of arrows across the napkin. "Here's the pipeline," he said. "Step 1, ingestion and chunking. You feed the system raw documents, statutes, cases, client memos, all the messy stuff. But the AI can't handle an entire case at once, so we split it into smaller pieces called chunks." "How small?" Cooper asked. "Usually a few sentences, maybe a paragraph," Jesse said. "Big enough to hold meaning, small enough to stay precise. But here's the kicker. If you chop it wrong, you lose context. Imagine separating a sentence from its footnote explaining what it actually means. The AI retrieves the chunk later but has no clue why it mattered. Got it, Cooper said. So chunking is like indexing, but with knives. Pretty much. Then comes embedding. Jesse drew a cloud of dots and circled a few. Each chunk is converted into a vector, a string of numbers that capture its meaning. It's like translating text into a language the AI can calculate. Two vectors that mean similar things sit close together in that space. So negligence and duty of care live next door to each other? Exactly, Jesse said. Now we store those vectors in a vector database. That's the part everyone ignores, but it's the real hero. Think of it as the world's most advanced legal library. But instead of filing by keyword, it organizes by meaning. Jesse drew one more arrow, this time pointing back into the LLM box. When you type a question, the system turns your question into a vector too. Then it searches the database for the closest matches. Conceptually, not just by words. It grabs the top few chunks, pastes them together with your question, and feeds all that to the LLM. That's how the model answers with context. So it's not magic, Cooper said. It's just very fast reading comprehension. Exactly, Jesse said. The LLM's output is only as good as what the retriever finds. Garbage in, garbage out. That's why improvements in retrieval have boosted the quality of AI research tools more than the models themselves. The vector database and how it indexes meaning matter more than people realize. Cooper leaned back, impressed. So when I see better answers in Lexis Protégé or Westlaw CoCounsel lately, you're seeing better retrieval pipelines, Jesse finished. Smarter chunking, better embeddings, faster search algorithms. The models are roughly the same under the hood, but they're being fed much cleaner, sharper context. Meaning, Cooper said, the LLM is like a lawyer who finally learned to ask a law librarian for help. Jesse laughed. Exactly. And the librarian learned to read the entire case law library in a millisecond. The conference hallway began to clear as the next session started. Cooper glanced at his watch. You make it sound so obvious, but honestly, this isn't how most of us think about it. We assume it's all about the brain, not the memory. Jesse folded the napkin carefully and slid it across the table. That's why I'm glad we ran into each other. There's a whole world inside that retrieval box that's changing faster than most people realize. He stood, slinging his backpack over one shoulder. I've got to moderate a panel, but let's keep this going. I can show you what's actually happening under the hood. You free next week? Cooper asked. We could set up a Teams call. Perfect, Jesse said. I'll bring diagrams. You bring skepticism. As they shook hands, Cooper tucked the napkin into his notebook, already thinking about how he'd explain it to his firm's attorneys. He didn't know it yet, but that napkin sketch was the start of a story that would change how he thought about AI forever. Part 2, the team's call inside the engine room. A week after their conference conversation, Cooper sat at his desk, nursing a cup of coffee that had long since gone cold. The Teams window blinked to life, and Jesse's face appeared, haloed by the glow of 3 monitors. Behind him, a wall of whiteboards looked like someone had tried to explain the meaning of life in math. Morning, Cooper, Jesse said. Ready to see what's really been driving these AI breakthroughs? Cooper grinned. Let's see if I can keep up this time. Good. Because today, we're stepping inside the engine room. This is where all the unglamorous plumbing makes the magic happen. Jesse shared his screen. A cloud of blue dots appeared, connected by faint lines. Here's your AI research assistant's brain, Jesse said. Every one of these dots is a chunk of text, a sentence, a paragraph, a small section from a case or statute. Together, they form a semantic map of the legal universe. He zoomed in. When you type a question like, what's the standard for summary judgment under Rule 56, the system doesn't keyword match Rule 56. It turns your question into a mathematical vector drops it into this cloud, and searches for the closest points. Text chunks that mean the same thing even if they don't use the same words. So it's not looking for exact matches, Cooper said. It's looking for meaning. Exactly, Jesse said. Let's stick with our law librarian analogy. It's like hiring one who doesn't just remember where the books are, but what they're about. He highlighted a path through the cloud. And that librarian is fast because of something called approximate nearest neighbor search, or ANN. Instead of checking every document in the database, ANN algorithms use shortcuts, like express elevators in a skyscraper. It sacrifices a hair of accuracy to get an answer 1,000 times faster. Cooper squinted. So we traded a dictionary for a GPS system. Right, Jesse said. Only this GPS runs on rocket fuel. Jesse pulled up a new slide. This one split into 2 circles labeled lexical and semantic. Here's where it gets interesting, he said. Pure semantic search understands meaning, but sometimes you need the exact words. Think of case citations. If I search for section 230, I don't want the AI to assume I meant similar liability shields. I want that exact statute. So we blend the two, he continued. Hybrid search runs a semantic search and a keyword search in parallel and then fuses the results. It keeps the conceptual matches but also grabs the exact ones. That's what lawyers expect, context and precision. Cooper leaned forward. That way, when I ask about economic duress in Texas contract law, it'll bring me the cases that use that phrase and the ones that discuss coercive bargaining power, even if they don't use those words. Exactly, Jesse said. Hybrid search is like having one librarian who knows the index and another who knows the author's intent, and they compare notes before answering. Example 1, researching a statute. Let's walk through something practical, Jesse said, pulling up a small demo screen. A text box read, find the standard for summary judgment under Federal Rule of Let me try that again. Find the standard for summary judgment under Federal Rule of Civil Procedure 56. In a traditional database, Jesse explained, you'd get every document containing the phrase Rule 56. The system doesn't care whether it's about summary judgment or procedural motions, but our RAG-based retriever embeds your question and finds sections of cases that actually explain the standard. The output appeared on screen. Summary judgment is appropriate where there is no genuine dispute as to any material fact, and the movement is entitled to judgment as a matter of law. That line came directly from Celotex Corp v. Catret, Jesse said. The system didn't keyword match it. It understood that you were asking for the test applied under the rule and retrieved the language explaining it. So the AI isn't just smarter, Cooper said. It's reading with comprehension. Exactly, Jesse said. That's what good retrieval architecture does. It teaches machines to read. Jesse opened another slide showing a column of filters. Court, jurisdiction, date, document type. Metadata filtering lets you narrow the universe before the search even begins, he said. Let's say you only want California state cases after 2020. The system filters the corpus first, then performs vector search within that subset. Faster, cleaner, more relevant. So it's like asking the librarian to check the Pacific Reporter shelves first, Cooper said. Exactly. That kind of pre-filtering makes huge databases practical for real legal research. Example 2, tracing precedent in a common law question. Jesse clicked into another demo. Let's try a common law research problem. Suppose you ask, how did Texas courts define the implied covenant of good faith and fair dealing? On screen, the AI retrieved cases, each with short summaries and citations. And to the librarian's chagrin, I will not read the entire citation. Texas courts do not recognize an implied covenant of good faith and fair dealing in every contract. The Texas Supreme Court has consistently held that such a duty arises only in the context of special relationships between the parties, which are marked by elements such as trust or an imbalance of bargaining power. Barrow, Shaver, v. Carrizo Oil and Gas. Second, in the absence of a special relationship, any duty to act in good faith is considered contractual in nature and does not give rise to an independent tort. Texas Champs Americana, Inc. versus Comerica Bank. Here's what's happening under the hood, Jesse said. The retriever finds multiple semantically similar chunks, each one discussing good faith. Then it ranks them using hybrid search. The system knows these cases define the concept even if they don't share keywords. And it's pulling the jurisdiction, date, and context automatically, Cooper said. Right. That's metadata filtering again. It keeps the answers legally coherent. You don't want an Illinois case sneaking into your Texas research. Jesse pulled up a visual of multiple interconnected servers. Now multiply that by 20 billion documents. To keep latency under a second, we shard and replicate everything across clusters. Shards are slices of the data processed in parallel. Replicas handle redundancy and balance the load. So when you hit search, hundreds of servers wake up, race through their pieces, and send the results back before you blink. Cooper shook his head. So a question that used to take me 20 minutes now takes a few seconds? Exactly. And that's why legal AI suddenly feels smarter. Not because the models got magical, but because the infrastructure finally caught up. Cooper leaned back. So better embeddings, better indexing, faster retrieval, that's what's driving the leap forward. The LLM's just right on top of it. Jesse nodded. Right. Think of the LLM as the lawyer and the retrieval system as the researcher who hands them the right case file every time. If the researcher is off their game, even the best lawyer gives a bad answer. He paused. That's why I keep saying the improvement isn't in how AI thinks, it's in how AI reads. Cooper smiled. You realize that line's going on a slide in my next firm presentation. Take it, Jesse said. Just make sure you spell approximate nearest neighbor correctly. ANN. Got it, Cooper laughed. Their call timer ticked toward the hour mark. I'm heading back to HQ next month, Jesse said. Why don't you come see it for yourself? You can meet the engineers and see how retrieval works alongside generation in real time. Bring a lawyer with you, someone who can push back when we start talking about AI's reasoning. Cooper grinned. I know just the person. Perfect, Jesse said. We'll have coffee, whiteboards, and enough acronyms to fill a casebook. The call ended. Cooper stared at his notes, lines and arrows connecting retrieval, embedding, and context. For the first time, he realized that AI in legal research wasn't about replacing the human mind. It was about building a better way for machines to understand what we mean when we ask a question. Part 3, the site visit, the lab where the AI learns to think. 3 weeks after their team's call, Cooper stood at the security desk of Jesse's office building, the glass and steel fortress where Jesse's team built the backbone of one of the top legal AI systems in the world. Beside him was Maya Rios, a litigation partner from his firm who'd reluctantly agreed to tag along. This feels more like a tech startup than a research company, Maya murmured, scanning the open workspaces and the whiteboards covered in mathematical hieroglyphs. That's because it is, Cooper said. They're the ones making our research tools feel like magic. Jesse appeared from around a corner, coffee in hand. Welcome to the lab. You must be Maya. I'm Jesse. We're going to ruin your sense of technological mystery today. Inside a glass conference room, Jesse drew two rectangles on the whiteboard, one labeled retrieval, the other generation. A thick line connected them. Last time we talked, we covered how we find the right data, Jesse said, tossing a marker in the air. Today, we're talking about how we use it. This is where RAG starts to grow a brain. Sounds terrifying, Maya said. Only if you think of it like Skynet, Jesse replied. Think of it more like a first-year law student who finally learned critical thinking. He drew a stack of boxes that grew larger as they climbed the board. Here's the problem, Jesse began. If you use tiny chunks for retrieval, you get precision but no context. The model can find the perfect quote, but it won't understand what it means. If you use big chunks, you drown the system in irrelevant noise. So you pick one or the other, Cooper asked. No, Jessie said. You do both. We call it small to big retrieval. The system searches using tiny chunks like sentences. But when it finds a hit, it expands outward to grab the surrounding context. It's like zooming out on a paragraph to see what the sentence actually refers to. He circled a portion of the diagram. We also link smaller chunks to bigger parent sections. Once a relevant sentence is found, the system automatically retrieves the larger block of text that contains it. That's what we call the parent-child retriever. Maya nodded. The AI doesn't just match words, it understands the legal argument's boundaries. Exactly. That's how it avoids misquoting or missing the nuance in a ruling. You'd be surprised how often meaning lives in the sentence before the one you searched for. Jessie switched to another whiteboard covered in sticky notes connected by red string. This, he said proudly, is what we call graph rag. Think of it as a legal detective wall. Maya raised an eyebrow. You mean like in crime shows? Precisely. Each node is a case, statute, or legal concept. The strings are relationships. Cites, overturns, interprets, authored by. Traditional vector search can find similar ideas, but it doesn't understand relationships. Graph rag does. So if you ask about a case, Cooper said, the AI can trace its entire family tree. You got it. It can start with one case and walk the network. See which cases cited it, which ones overruled it, which judges wrote them, and even which statutes they relied on. LexisNexis built their Shepherd's knowledge graph around this idea. It's how Lexis Protégé can track how a precedent evolved over time. Maya tilted her head. That's actually impressive, but also a little creepy. Law is creepy, Jessie said. We just gave the machine a map of how it all connects. Jessie waved to a technician behind a glass wall. Okay, you've seen retrieval, now let's watch reasoning. On a nearby monitor, a legal question appeared. What is the standard for negligent misrepresentation under Delaware law in commercial transactions? Below it, lines of text flashed in rapid succession. Searches, filters, citations, and retrieval calls. The agent starts by making a plan, Jessie said. It decides what it needs to know. Statutory background, case interpretations, elements of the tort. Then it runs searches, analyzes results, checks relationships, and synthesizes everything into a structured memo. Maya leaned forward as a formatted summary appeared. Elements, key cases, and contrasting interpretations. That looks like something I'd assign to a first-year associate, she said. Exactly, Jessie said. Thomson Reuters calls this deep research. It mimics human workflows. The agent plans, executes, verifies, and writes. It's no longer just retrieving information, Cooper said. It's reasoning through it. Yep, agentic AI is the next leap, Jessie replied. You can't trust an AI to act autonomously unless the retrieval foundation is rock solid. Now that we have reliable structured context, hybrid search, small to big retrieval, knowledge graphs, we can finally build AI that behaves like a researcher and not a parrot. Maya folded her arms. But can it argue, interpret, exercise judgment? Jessie smiled. Not yet. It reads better than any of us, but it doesn't decide. It doesn't have opinions or risk tolerance. Think of it as an infinitely patient analyst, not a lawyer. It gives you everything you'd need to make the judgment call. Then it's a force multiplier, she said quietly, not a replacement. Exactly, Cooper said. It levels up everyone who uses it. Jessie nodded. And that's why we're seeing such leaps in tools like CoCounsel, Protégé, and Vincent. The infrastructure got good enough for the AI to stop hallucinating and start reasoning. An hour later, they stood in the lobby again. Maya was silent, her lawyer's mind turning over what she'd seen. That was unsettlingly impressive, she said finally. You see what I mean now, Cooper said? The future of legal research isn't just about better answers. It's about systems that know why they're right. Jesse handed Cooper a visitor's badge as a souvenir. Keep that. You'll need it when we start testing the next phase. Multi-agent systems. Think of it as an AI research team that talks to itself. Maya shook her head. I'm both fascinated and mildly terrified. That's the correct reaction, Jesse said. Welcome to the edge of reason. Part 4. The round table, where it's all heading. 2 weeks later, Cooper found himself in yet another glass-walled conference room, this time overlooking downtown Chicago. Jesse had gathered a few of his team members, along with Maya, who was still visibly skeptical of AI's newfound confidence. All right, Jesse said, queuing up a slide deck titled The Market in Motion. You've seen the guts of how it all works. Now let's talk about who's actually winning the race. Finally, Maya muttered. The politics of it all. Jesse advanced the slide, which split into 3 columns labeled Thomson Reuters, CoCounsel, LexisNexis, Protégé, and vLex, Vincent AI. Each of these companies is taking the same toolbox and building something very different on top of it, Jesse said. Vector databases, RAG pipelines, knowledge graphs. Think of it as 3 law students with the same casebooks but completely different study habits. Cooper smiled. I feel a metaphor coming. Thomson Reuters is the perfectionist, Jesse said. They built CoCounsel as a reliability-first system. Their philosophy is simple. Don't trust the open web, ever. Their AI grounds every response strictly in Westlaw and practical law. Curated, verified, and citation checked to death. So they traded breadth for authority, Maya said. Exactly. Their deep research agent plans multi-step workflows just like a senior associate. It searches Westlaw, traces key site links, reviews secondary sources, and assembles a full memo. It's agentic AI at its most conservative, structured, explainable, and tested by humans before release. Sounds like the big law model, Cooper said. Slow, but defensible. Right, Jesse said. Then we've got LexisNexis, the cartographer. Their secret weapon is the shepherd's knowledge graph. It maps how cases, statutes, and judges connect. Citations, reversals, relationships, all the legal DNA that vector search alone can't see. Maya nodded. So that's why Protégé can trace case history like it's following a bloodline. That's correct, Jesse said. Lexis took the graph RAG approach and merged it with personalization. Protégé doesn't just show the law. It learns your firm's law. It can integrate your document management system, understands your drafting style, and builds from your own precedents. It's like a paralegal who already read everything your firm ever wrote. Which means, Cooper added, if you switch firms, you lose that history. Bingo. It's sticky by design. The more you use it, the more it adapts. And vLex? Maya asked. vLex is the experimenter, Jesse said. They built Vincent AI to be global and flexible. Their system is model agnostic. It picks the best language model for each task, whether that's OpenAI, Anthropic, or something else. Their edge is their retrieval layer, highly customized, multi-jurisdictional, and multilingual. International coverage, Cooper said. That's their play. Exactly. And their new Vincent Studio lets firms design their own AI workflows without code. They're basically saying, here's the toolbox, build your own CoCounsel if you want. Jesse switched slides again. The screen now showed a racetrack labeled the RAG Arms Race. Here's the truth, he said. The foundation models are converging. GPT-5, Claude, Gemini, they'll keep getting better, but those improvements are incremental now. The real competition is happening under the hood. Retrieval architecture. Meaning whoever builds the best librarian wins, Cooper said. Exactly. The smarter the retriever, the better even a mediocre model performs. That's the new moat. Curated data plus intelligent retrieval. Maya frowned. So in 5 years, it won't matter which LLM a company uses? Not much, Jesse said. Access to LLMs is getting commoditized. The secret sauce is the system feeding them, how you chunk, index, filter, and connect knowledge. He leaned forward. That's why every vendor is racing to improve retrieval quality. Better vector search, more efficient metadata filtering, context-aware chunking. They're squeezing every ounce of intelligence out of how AI reads, not how it writes. Jesse moved to the final slide, showing an illustration of a lawyer and an AI assistant standing side by side, both reviewing documents. This is where it's going, he said, agentic AI. Systems that can plan and execute complex research tasks autonomously, and personalized AI that understands your firm's knowledge base. So AI is a research associate, not a search box, Cooper said. Yes, Thomson Reuters is already doing it with deep research. Lexis is chasing it with Protégé. vLex is betting on letting users design their own agents. They're all moving toward AI that doesn't just respond, it acts. And when it acts, Maya said, it has to be right. Jesse nodded. That's why retrieval is everything. You can't have autonomous reasoning if the information it is reasoning from is garbage. He closed the laptop. That's the irony. The real intelligence of AI isn't in how well it predicts words. It's in how well it reads the world before it speaks. The meeting wound down. Cooper looked out the window, the city lights flickering against the glass. You know, he said, we've spent a century teaching lawyers to write better arguments. Maybe the next century is about teaching machines to read better. Maya smiled faintly. Then I hope they're better readers than most of the lawyers I know. They already are, Jesse said with a grin, and they don't bill by the hour. Part 5, The Flight Home, Reading the Future. The sun was setting as Cooper's flight banked over the Chicago skyline. He pressed his forehead against the cold window and watched the city dissolve into grids of LED light. Somewhere below, Jesse and his team were probably still in their lab, teaching their machines to read the law a little better. Maya sat beside him, earbuds dangling around her neck, half asleep. Her notepad lay open between them, pages covered in shorthand notes from the past 2 days. Small to big, knowledge graphs, retrieval as a new intelligence. Cooper smiled. You ever think we just watched the next generation of Westlaw being born? Maya opened one eye. I think we watched the next generation of lawyers being born, she said. One's made of data. He thought back to Jesse's final slide. The real intelligence lies in the reading. For years, the industry has obsessed over the models, the brains of AI. Bigger models, more parameters, flashier benchmarks. But what Jesse had shown them flipped that thinking on its head. The breakthroughs weren't happening inside the model anymore. They were happening around it. With the retrieval pipelines, vector databases, and orchestration systems that decided what the AI should even look at. The leap forward in legal research wasn't about teaching machines how to think better. It was about teaching them how to read more intelligently, more contextually, and more responsibly than any human could. In the end, Jesse had been right. It wasn't a revolution in language. It was a revolution in comprehension. He flipped through his own notes, underlining a few phrases from Jesse's presentation. Access to LLMs is no longer an advantage. Retrieval quality determines trust. The moat is in the data. That was the quiet truth reshaping the entire legal AI market. Whoever built the best retrieval architecture would own the next era of legal research. The smartest system for surfacing relevant, authoritative, contextual information would win. Thomson Reuters was betting on authority. LexisNexis was betting on relationships. vLex was betting on flexibility. But all of them, he realized, were really betting on the same thing: precision context. Maya stirred again. You're still thinking about that AI, aren't you? Yeah, he said. I can't stop wondering what this means for the profession. If AI can already do multi-step research, how long before it handles strategy? Maya yawned. You're forgetting something. Law isn't only about finding the answer. It's about choosing which answer to stand behind. Machines won't have courage or fear or judgment. Maybe that's the new division of labor, Cooper said. AI finds the truth. We decide what to do with it. Maya smiled faintly. Then let's hope we keep choosing well. As the cabin lights dimmed, Cooper opened his notebook and pulled out the napkin Jessie had given him back at the conference. The ink was smudged, but the rough sketch still made sense. RAG to retrieval to vector database to generation to answer. It was primitive and elegant at the same time. An entire philosophy condensed into one wrinkled square of paper. He added a final note beneath it in his own handwriting. The AI that wins isn't the one that talks the best. It's the one that listens the hardest. He folded the napkin carefully and slipped it back between the pages. Outside, the lights of the city faded into darkness. Somewhere in the hum of the engines, Cooper could almost hear Jessie's voice echoing from their first conversation, half amused, half prophetic. We didn't make AI smarter. We taught it how to read. Thank you, Greg Lambert.